Hello, welcome to Millionlights. My name is Pratik Shah. I am an assistant professor in Dr. D.Y. Patil School of Engineering. In the previous module, we had discussion on LCDs. We had seen various instructions and how they work. In this module, we are learning servo motors. We will explore servo motors and how it can be used and what all application it has. Servo motors. Now this is one servo motor. Now let us first see how it is different from DC motors. In DC motors, we had two pins, and with the help of those two pins, we can make it move in the clockwise direction or anti-clockwise direction. We connected it with VCC and ground. If we are connecting in that direction, it was rotating in clockwise direction. If we reverse the polarities, it was rotating in anti-clockwise direction. So that was how the DC motor was working. So it was having a complete 360 degrees radius, that it was completely rotating for 360 degrees, and it so on and so forth. But we did one more thing with DC motors. We did speed control. Suppose I have a DC motor with 120 rpm, 200 rpm or 500 rpm. I was able to control the speed of it. How did I do it? I did it with the help of PWM. I used pulse width modulator. With the help of that, I was able to control the speed of it. So that was regarding DC motors. Now this is servo motors. Now how is it different from DC motors and what is it made of? First thing that I would like to tell you is that this motor can rotate only for 180 degrees. That means if you start from in here, it can rotate till this point only. Now further, if you apply pressure, it won't rotate because it is fixed. So the rotation of this is only 180 degrees. First thing, unlike DC motor, it cannot rotate for 360 degrees, it will rotate only for 180 degrees. That is the first thing regarding servo motors. Second thing, if you use it and you provide a particular signal, what signal we'll discuss later. If you provide a signal so that it is fixed at 90 degrees, it will be at 90 degrees, and whatever pressure you apply, it won't rotate. So now if I apply the pressure, it is rotating, fine. Beyond one point it is not going, okay, but it is rotating now. But if I apply a signal to it and it is set to suppose this direction, then it will not change its position even if I apply this external force. Now I can easily rotate it, but when I give it proper signal, I will not be able to rotate it unless and until I don't or I do not exceed the strength that it has. That is, it has got a torque. Some torque is given with each and every servo motor. We have got specification where they mention the torque. So based on that torque, if we apply torque that is more than that, then only it will move, else it will be fixed in that direction. Now the third point that come in our mind is, why should we go for the servo motors? It cannot even rotate for 360 degrees, so it is useless. We cannot use it in robots. If that is your thinking, then I beg a pardon, it's not that correct, because it is most useful thing in grippers. Now robots, we have wheels for making it move in forward backward direction and move around the places. But if you want to grip some object, if you want to pick up anything, or if you want to have that kind of thing, DC motor is not good, because DC motor does not give you that good control. Suppose I want to grab something, so I want to go at this degree and I want to grab it. So at that time you cannot apply motors. You can make a gear shaft assembly, but you cannot use DC motors because you cannot control its speed. And to keep it at this direction, this is the shaft, say you want to make the grippers come at this angle and you want them to be fixed in here. You cannot make it with DC motors, they will go back. Then you have to apply the pressure. If you apply the pressure or apply the voltage, it will go forward. So you want to keep it at a constant pressure. At that time you want to use this servo motors. So for making grippers and all, we require this. Along with that, robotic control arms or robotic arm, bionic arm, in that also we require. When we make such kind of assemblies which are there in industries, where we want to pick up one substance, we place it some other where, so you want exact degrees or exact, the accuracy is very important, and we want to be stiff and we want to be strong at that position. We don't want it to go backwards, if we want it to be at same position. So at those places we use servo motors. Okay, so we have understood what is the difference between servo motor and DC motor. Now let us see what is it made of and how we can use it. What is it made of? It is made of four components. First component, you will be shocked to know it is normal DC motor. So inside this we have a normal DC motor. That is first thing. Second thing is gear reduction unit. After gear reduction unit, we have a position sensing device. Now the position sensing device is usually a potentiometer that we have already discussed, and the last part is the control circuit. So control circuit, potentiometer, gear reduction unit and DC motor. So DC motor, we apply gear reduction unit so that the motion is restricted. Then we have a position sensing device which will sense the position of it. Suppose it is at 90 degree, it is at 0 degrees, 180 degrees, or whatever may be the angle. The position we have, to sense the position, we have a position sensing device that is nothing but our potentiometer. With the help of the shaft, it identifies the position of it. And then we have a control circuit. This control circuit compares the position of our servo motor with the help of potentiometer and the desired output. So for a desired output, suppose I want to move it at an 78 degrees, then for 78 degrees I will give it some input. That input is given to control circuit and it takes the data as a feedback from our position sensing circuit or position sensing device. So it compares the position sensing device's reading and the signal that is received from the user, compares it. Based on that, it generates the error signal, and due to that it changes the direction or it rotates. So this is how it works. It has got DC motor, gear reduction unit, position sensing device and a control circuit. Okay, so we have understood how it is made. Now we'll understand how to operate it. Now operating principle of it is quite simple. For this you can see we have only 3 pins, that is a 3 pin device is given to us so that we can make the connections. Now these 3 pins are having a particular color code, that is orange, red and brown. Now in these 3 pins you will be very happy to know that 2 pins are VCC and ground. So only 1 pin is the signal, and based on that we can rotate it. The center pin, that is red, is for power supply, that is for providing 5 volts. Then brown is for ground, so we will connect it to ground pin, and then the yellow wire, that is the signal. So if you want to control it, you want to make it to rotate or move at a particular direction, you have to provide VCC and ground in this, and then you have to use your controller or anything to give a signal to this yellow line. Now what signal shall I give this thing to rotate? Now for rotating it, we have to give a PWM signal. So PWM is pulse width modulation signal that we have already discussed, and that concept we are going to use here. So based on PWM signal, the position is fixed. Now if you are giving less PWM, then the degree of rotation means the degree or the angle is less. If you give 50% duty cycle, it will rotate at 90 degrees. If you give if you give 100% duty cycle, it will go to the place that is on the 180 degrees. So based on the duty cycle or the PWM's signal, the position is fixed. So this is very simple to use. 3 pins, VCC, ground and signal. Now the advantage of this is it requires very less power. Now you might recall that for using DC motors we require L29 3D IC. So L29 3D IC was used to supply power to DC motor and then it was rotating. But I can directly connect this to my Arduino, and from my Arduino I can control this, because the power required for the operation is very less and it is very power efficient. So this is how this servo motors works, and this is the difference that is between DC motor and servo motor. Now to explore further on this, we will take 2 experiments. First experiment is to make it move from 0 degrees to 180 degrees and once again from 180 degrees to 0 degrees. That is the first experiment. Now we will start understanding the first experiment. Now let us see the circuit. we are making a servo sweep, that means a circuit that will make our servo motor rotate from 0 degrees to 180 degrees. Now the circuit is quite simple. As discussed earlier, we just have to connect 3 pins, and those 3 pins are VCC, ground and the signal pin. The VCC is connected to 5 volts on the Arduino, the ground pin is connected to the ground of the Arduino, and the signal pin is connected to pin number 9. Now I am connecting it to pin number 9 because pin number 9 has the capability of giving PWM signal. Okay, so this is the simple connection that we have. Then we have to write the code, but along with that, one more additional thing we are doing. We are placing a 100 microfarad capacitor along with, in parallel with, VCC and ground, that is pin number 1 and 3 of the servo motor. Why we are doing this? We are doing this because initially during the program, if our servo motor has to move at a various or a very different position, suppose it is at 0 degrees and initially the position set is 180 degrees, then at that time it requires a lot of current. So when it requires a lot of current, our Arduino can get reset. So to avoid this, what we are doing is we are providing a capacitor in parallel with VCC and ground, so that it will store the charge, and then when it requires the lot of voltage and power, the capacitor can provide it. So we will be adding that in series. Okay, so this is the simple circuit. Now we will build it. For this experiment, we will require Arduino board, capacitor. We are using 100 microfarad capacitor, breadboard, servo motor, jumper wires and USB cable. First of all, we will take this servo motor, and for that we have to connect 3 pins. Now this is a female jumper, hence we have to connect male jumpers to it. So I will take 3 jumpers. Okay. First I will take red jumper and I will connect it to the first pin. Okay. So this is my VCC. Now I will take black jumper, and that jumper is connected to second pin, and finally third jumper, that is for the signal, is connected here. Okay, so we have made these 3 connections. Now in them, the middle one, that is the signal, is to be connected to pin number 9. So this is 8, this is 9. This is one connection that we had to do. Now there are 2 more connections. First we are connecting VCC in here, ground in here, and that in series with that, or in parallel with that, I have to connect this 100 microfarad capacitor. Now how we have to make sure that we are making a proper polarity also, that means we are connecting proper terminals. Now the bigger terminal is a positive terminal and the smaller one is negative terminal. That is one way of identifying. Or the second way is that whenever we have smaller terminal, here the negative sign is available. So we can see the negative sign in here. So from that we can identify the polarity of it. So the positive terminal goes in VCC, the negative one goes in ground. Okay, so positive is going, negative is going. Now I have to make the next connection, that is connecting ground and VCC from my Arduino board to these pins. Okay, so I have connected the ground, I have connected the VCC. Okay, that's it. Very simple connections. Connect positive of servo to positive of Arduino, negative to negative, and pin number 9 of Arduino is connected to signal pin. But to ensure that Arduino doesn't reset itself, we are adding a capacitor in VCC and ground pin of the servo motor. So this is the circuit. Now what we'll do is we'll connect it to PC with the help of USB cable. Okay, so with the help of USB cable we'll connect it to PC. Now we'll see the programming and then we can talk about the expected output. Now before programming, I'll discuss about the expected output. The expected output is that my servo motor rotates from 0 degrees to 180 degrees. Uh, in each and every this rotation or change, I am having, and the resolution is 1 degree. So for each and every 1 degree, I will see the change. Now depending upon the delay that I use, I will be able to see the change. So the output is that servo motor will move from 0 to 180 degrees and back from 180 to 0. Okay, now we'll see the code and then the output. Now let's see the programming part. This is the program. Program is quite simple, very small, very few lines. Now let us split the code and see one by one. The first instruction is hash include servo.h. So here, to make our job very easy, instead of providing PWM signal by ourselves, we are using a servo.h header file that is available with the Arduino. So we are using that. It will give us few of the instructions such as my servo.attach and then my servo.write. So these instructions will be very beneficial. Hence we are using hash include servo.h header file. Then we are making a constructor of it. The name of the constructor is my servo. So it is the constructor that we have made. So we'll be using methods associated with it. Then we are initializing a global variable, and the name of the variable is POS, and the value that is assigned to it is 0. So I am declaring a global variable. It is of integer type, and the name of the variable is POS, that is for position, and I am assigning a value to it, that is 0. Okay, so this was the first part. Then second part is void setup. In void setup, I just have to do one thing, that is my servo dot attach in bracket 9. That means with the help of the constructor that I have made, I am using a method called as attach, and to that method I am sending a parameter that is 9. That means connect pin number 9, or pin number 9 from Arduino is connected to the servo motor. So whatever instructions you want to give, with the help of pin number 9 we can do. So my servo dot attach in the bracket the pin number. This is an important instruction that is to be used always when we are using servo motor and we are attaching it to any pin on the Arduino. Then we go inside void loop. In void loop we have got few things. First thing that we want to do inside void loop is we want to rotate our servo motor from 0 degrees to 180 degrees, and while doing that we want the step to be equals to 1 degrees. So for that means we want to change the value of position from 0 to 180 degrees. Now if you want to set a servo motor in a particular position, say I want to make my servo motor to go at a position of 80 degrees, then I have to write my servo dot WRIT, and inside bracket I have to write the degree at which I want it. I want it at 72 degrees, then my servo dot write inside bracket 72. It will directly go to 72 degrees. So my servo dot write is the instruction that is used to make it to go at a particular degree. Now I want it to go from 0 to 180 degrees at a step of 1. So 0, 1, 2, 3, 4, 5, 6. In that way I have to write 180 instructions. My servo dot write 0, my servo dot write 1, my servo dot write 2. So instead of writing 181 instructions, what I'll do is I'll use a for loop, and here my servo dot write is same, just POS, the value of POS is changing. So I'm using a for loop. The for loop, in that for loop I'm using a variable, the name of the variable is POS, that is initialized to 0. Then till the value of position is less than or equals to 180 degrees, I am executing this loop, and I am incrementing the value by 1. So you can either do POS plus plus or POS plus equals to 1. This is also perfectly alright. So what I am doing is I am changing the value of position from 0 to 180, and till this time the condition is true, I am going inside the loop, and inside the loop I am changing, or I am writing my servo with a particular angle, that is from 0 to 180 degrees. So this for loop will make my servo to move from 0 to 180 degrees at a step of 1 degrees per 15 milliseconds. Okay, now the next part. Now after this part the servo will go to 180 degrees. Now I want to bring it back from 180 degrees to 0 degrees. So I'll use another for loop where the position will be set to 180 degrees. That position POS is the variable that I'm using. It will be set to 180 degrees, and it will be brought back to 0 unless and until coming to that the decrement, here we are using decrement variable, and it is decremented by 1. So 180, 1, 179, 178, in this way it will be coming back till 0. So for loop is used, and in that I am writing position, so my servo.write is used to write the position, and then a delay of 15 millisecond is used. So this is quite simple code. Here just two for loops are used. First for loop to move it in the upwards degree, and then to make it come back. So this is regarding the code. Now we'll write the code onto Arduino IDE, upload it, and we'll see the output. Okay, now let's upload the code onto Arduino IDE. Before that, I'll place it here so that it is easier to see the rotation. This is the code. I have already typed the code in the Arduino IDE to save the time. Same code that we have seen earlier. Now I'll check whether the code is correct. We'll check whether some of the errors are present. No, there is no error. Now we'll upload the code. Okay. Yes, so this is the initial position. From that it is going to 180 degrees and back down. So from 0 to 180, and from 180 to back to 0, because we had two for loops. One was increasing it from 0 to 180, other one was decreasing it from 180 to 0. Now you might not see each and every change in the degree, because the delay that we have given is very low, that is just 15 milliseconds. Now what I'll do is I'll increase the delay, I'll make it 150 milliseconds, and then we'll see how we can see each and every step. Okay, I'll change it. Okay, I'll make it 150, and here also I'll make it 150. Then I'll upload the code. The code is getting uploaded. Okay, there is an error. One extra semicolon was found. I don't know how. Okay, now we'll compile this code and we'll see whether it's okay. Good. ठीक है ठीक okay. Okay. Now we'll compile the code. We'll see whether it's okay. Yes, it's fine. Now we'll upload it. We'll see the output. Slowly it is taking a gap of 150 millisecond to change for 1 degree. So by 1 degree it is changing its axis, and it will reach 180 degrees, and after that slowly it will go back to 0 degrees. So it is going up, it will stay there and will slowly go down. Now since we have changed the delay, it is doing this transition very slowly. If we increase the delay, we won't understand the effect. Now we'll do the second experiment with servo motors. In this experiment, we are going to control the rotation of servo motor based on the position of potentiometer. So we are using a potentiometer, and based on the position of potentiometer, we want our servo motor to rotate. So if we change the potentiometer, the servo motor will also rotate. So the degree of servo motor will be changed with the help of this potentiometer. For this experiment, we will require Arduino board, potentiometer, 100 microfarad capacitor, breadboard, servo motor, jumper wires, USB cable, and a screwdriver. Screwdriver is used to rotate the potentiometer. Now the circuit diagram of it is quite simple. The same thing is used for servo motors 1, 2 and 3, everything is same. Just one change we have, and that change is about the potentiometer. In the previous circuit we are keeping the same thing, just we are adding a potentiometer. So potentiometers, positive terminal goes to VCC, negative goes to ground, and the center terminal is going to A0. So based upon the voltage that we provide to A0, we are rotating or moving the servo motor. So now we'll build the circuit. Now we'll build the circuit. For this, we'll first take breadboard. Okay. Now the first thing that we'll do is we'll make a VCC and ground rail. So 1, 2, 3 and 4. This is VCC and this is ground. So we have two rails, VCC and ground. Now we'll take servo motor, and from that servo motor we'll connect. Okay, so first I'll keep VCC in here, ground in here. So VCC and ground I have connected, and this output pin is going to pin number 9. Okay, so this was regarding servo motor. Now to the servo motor I have to connect this 100 microfarad capacitor. I will connect it across the VCC and ground. Okay. Now I will connect the VCC of servo motor to the circuit VCC, the ground of servo motor to ground, common ground. Fine. Now this part is over. Only one part is left, that is to connect the potentiometer. Okay, so I have connected the potentiometer, the positive terminal. Okay, so it's connected. Positive terminal goes to VCC, negative terminal goes to ground. Actually there is no such thing as positive and negative terminal, it's just 3 terminals, 1, 2 and 3, but it's easy to use that. And the center terminal, that is the output, will be given to A0 pin, that is on the Arduino board. So we are using potentiometer, we are connecting it to 5 volts and ground, and the center, that is wiper, is connected to A0. We are connecting servo motor, VCC ground is connected, and across that we are connecting an 100 microfarad capacitor, and then the output pin is connected to pin number 9 of Arduino. For that we'll get a PWM view. Fine. So with this we complete circuit. Now we'll see the code and then we'll see the expected output. Now we'll see the code for servo knob. In this we are using potentiometer. So based on the value of the potentiometer, we'll change the axis. Okay. So we have made the circuit. Now we'll see the code. The code is very simple. It is much simpler than the previous one. Here the initialization of servo.h including the library is same. Making and constructor my servo, that is also same. Then here we are declaring a variable called as VAL, and that is a global variable. If you want you can also make it as a local variable, but we have made a global variable. Then in void setup, two things are there. One is my servo dot attach 9, which tells that I am going to use servo motor on the 9th pin. Then pin mode A0 input, because A0 pin is the input. It is the point where the potentiometer's middle terminal is connected. So that is the input, that is what I have to initialize. Then we are talking about now void loop. The first instruction is to read the value that is available at A0. So at A0 the value is read, and the value is from 0 to 1023. because we are using ADC. ADC is having 10-bit resolution, so it can count from 0 to 1023, that is 2 raised to power 10, that is 1024. So it can count from 0 to 1023. Okay, so it will give us 0 when the output is 0 volts, it will give us 1023 when the output is 5 volts. So based upon that it will give us output. But we want to rotate the servo in proportion with that. Now how can we do that? For that we are using the function called as map. In the previous module also we had used the function called as map. Map function converts one range into another one. So I am giving the I am calling the map function. For that I am giving the value of the variable val, and that there the range is set from 0 to 1023, that is the input range, and the output range will be from 0 to 180. So corresponding to that, so according to the proportional to the input I am giving the output, and the output is from 0 to 180, and that output can be directly given to servo, and the servo will definitely rotate according to that. Now after I get the value from 0 to 180, I will use the instruction my servo dot write. So it will write the value to the servo motor, and then I am giving a delay of 15 milliseconds. So this cycle is repeated for every 15 milliseconds. I read the value, I map it, and I put that value on the servo motor. So now we'll upload the code. Before uploading the code, we will connect our Arduino board to the PC. Okay, we have connected it. Now we have this code. We'll first compile it. To save the time, the same code is written here. Yes, and now I'll upload the code. Okay, so I am uploading the code. Okay, so the code is uploaded. Now it is fixed, and it is due to the value of potentiometer. It is at this location. Now I cannot. If even if I apply the power, it is not rotating. Okay, because it is on. Now I'll change it. I'll change. See, as I make these changes, the position is also changing. You can see that. So we have created a servo knob with the help of our potentiometer. This servo is changing. So you can make it rotate in the full scale depending upon the value of the potentiometer. We are getting change in the output of the motor. These kind of things can be used in making bionic arms. So instead of here we are using potentiometer, at that time you can use LDR or some other thing, some other analog parameters or pressure sensors, something like that. Based on that we can measure it, and we can make an bionic arm where the rotations are made. So this can be used in lot of places in robotics. Hope you like the video. If you have any queries, you can find us on Facebook by the name Millionlights, or on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.